A motherboard is also known as the primary circuit inside the computer and where the central processing unit, CPU, memory slots, drives, and other peripherals. A motherboard provides the electrical connections by which the other components of the system communicate. It also consists of central processing unit and hosts other subsystems and devices. An important component of a motherboard is the microcontrollers supporting chipset, which provides the supporting interface between the CPU and the various buses and external components. This chipset determines to an extent the feature and capabilities of the motherboard.
Components of motherboard. The motherboard is the primary printed circuit board (PCB) in a computer that connects and communicates with all other components in the system. The components of a motherboard can vary depending on the make and model, but some of the essential components found on most motherboards are CPU socket. The CPU socket or CPU slot is where the processor or CPU is installed. Chipset. The chipset is a set of microchips that manages communication between the CPU and other components such as RAM, storage devices, and expansion cards. RAM slots. The RAM slots are where the system memory or RAM is installed. Expansion slots. The expansion slots provide a way to add additional components to the system such as graphics card, sound card, and network cards. Storage connectors. The storage connectors such as SATA and M2 a way provide a way to connect storage devices such as hard drives and solid state drives SSDs to the system. Power connectors. The power connectors provide power to the motherboard and other components in the system. Input output ports. The I/O ports such as USB, Ethernet, and audio ports provide a way to connect external devices to the system. BIOS. The basic input-output system (BIOS) is a firmware that initializes the hardware during system startup and provides an interface for configuring system settings. Clock generator. The clock generator generates clock signals that synchronize the timing of various components in the system. Voltage regulator module (VRM). The VRM is a component that regulates the voltage supplied to the system and other components in the system. These are some of the primary components found on most motherboards. Other components such as audio and networking chips can also be integrated into the motherboard.
Hello, I am Jandavi Averi from B Division. I am going to explain the types of motherboards. There are several types of motherboards available on the market having unique features and specifications. So the important types of motherboards are ATX, which is Advanced Technology Extended. ATX motherboards are common type of motherboards used in desktop computers. They measure 12 inches by 9.6 inches and have a variety of expansions. ATX motherboards are ideal for gaming and other high performance applications as they offer a lot of room for customization and expansion. The second type of motherboard is Micro ATX. Micro ATX motherboards are smaller than ATX motherboards, measuring 9.6 inches by 9.6 inches. They have fewer expansion slots than ATX motherboards, but they still have enough space for multiple slots and RAM slots. Micro ATX motherboards are a good choice for budget gaming systems or compact desktops. The third type of motherboards is Mini ATX. Mini ATX are even smaller than Micro ATX boards, measuring 6.7 inches by 6.7 inches. Despite their small size, they still have one PCLE slot and one or two RAM slots. The fourth type of motherboard is EATX, which is Extended ATX. EATX motherboards are larger than ATX motherboards, measuring 12 inches by 13 inches. They have more expansion slots than ATX motherboards and are designed for high-end working and servers that require multiple CPUs, GPUs, and high networking. The fifth type of motherboard is BTX, Balanced Technology Extended. BTX motherboards were introduced by Intel as replacement for ATX motherboards, but they were never widely adopted. BTX motherboards are designed to improve airflow and reduce noise in the system. They have a different layout than ATX motherboards and require a different case region, which is one reason why they never became popular. The sixth type of motherboard is ITX, Information Technology Extended. ITX motherboards are designed for embedded systems and small form factor PCs. They are small, measuring 3.7 inches by 2.8 inches, and are often used in industrial or automotive applications. They have fewer expansion slots than other types of motherboards, but are ideal for low power applications that require small footprint. The seventh type of motherboard is Pico ITX. Pico ITX motherboards are even smaller than mini ITX motherboards, and are often used in embedded systems, robotics, and other specialized applications. So, when choosing a motherboard, it is important to consider the form factor, compatibility with other components, and features that you need for your specific.
The motherboard is the main printed circuit in a computer that connects all various components, including the central processing unit, memory, storage devices, and peripherals. The features and specifications of motherboard can vary widely depending on manufacturer and intended use the computer. Here are some common motherboard features and specifications. Form factor. The form factor of motherboard refers to its physical size and shape and determines which type of computer case it can be installed in. Common factors include ATX, micro ATX, and mini ATX. The second is CPU socket. The CPU socket is connector on the motherboard where the processor is installed. The socket type must match type of processor being used, such as Intel LGA 1200 and AMD AM4. The third is chipset. The chipset is set of chips that controls communication between the CPU and other components, including the memory, storage devices, and peripherals. The chipset can affect the motherboard's performance and its feature. The fourth is memory slots. The memory slots are where the RAM modules are installed. The number and types of memory slots can affect maximum amount of memory that can be installed as well as speed of the memory. The fifth is expansion slot. Expansion slots are used to add additional components to the motherboard, such as graphic cards, sound card, or network cards. Common expansion slots include PCI, PCLE, and M2. Storage connectors. The storage connectors are on the motherboard determine which type of storage device can be installed, such as SATA or NVMe SSDs. The number of connectors can affect the number of drives that can be installed. The seven is USB ports. USB ports are used to connect peripheral devices such as keyboard, mice, and external hard drives. The number and types of USB ports can affect the type of devices that can be connected. Audio 8 is audio and networking. Some motherboards include built-in audio and networking capabilities such as Ethernet ports and audio jacks. The quality of these components can affect the overall performance of the computer. The ninth is overclocking feature. Overclocking is the process in which speed of the CPU or other components beyond their rated specifications. Some motherboards include features that make it easier to overclock, such as BIOS settings or automatic overclocking tools. The 10th is BIOS. The basic input output system is firmware that controls the boot process and other low level functions of the motherboard. The BIOS can affect the performance and feature of the motherboard and can be updated to add new features to fix the bugs.
Good day everyone. Today I would love to talk about the importance of maintaining and upgrading the motherboard of your computer. The motherboard is the backbone of your computer system, and it is responsible for connecting all the different components and ensuring they work together seamlessly. Over the time, dust can accumulate on the motherboard, which can cause it to overheat and potentially lead to the component failure. This is why it is essential to regularly clean your motherboard using compressed air or soft brush to keep it free from the dust and the other contaminants. Moreover, upgrading your motherboard can significantly improve the overall performance of your computer. A new motherboard can support faster processor, higher RAM capacities, and better storage options, allowing your computer to run more smoothly and handle more complex tasks. However, upgrading your motherboard can be a complex process, and it is essential to have a basic understanding of computer hardware before attempting it. It is also crucial to ensure that any new component you purchase are compatible with the motherboard and the other computer hardwares. In conclusion, maintaining and upgrading your motherboard is essential for keeping your computer running smoothly and efficiently. Regular cleaning can help prolong its lifespan, while upgrading it can improve its performance and capabilities. Remember to exercise caution and seek professional help if you are unsure about the process with upgrading your motherboard. Thank you for listening.
The future of the motherboard. The technology is likely to be focused on improving performance, increasing connectivity options, and reducing power consumptions. Some possible advancement that we may see include increased integration. In the future, we may see the more integration component onto the motherboard, such as CPU, memory, and storage. This could lead to more impact and efficient designs, faster data transfer. With the increased need for faster data transfer rates, we can expect future motherboard to support faster interface such as PCIe 5 and Thunderbolt 4. More connectivity options. Future motherboards may support more connectivity options such as Wi-Fi 6E, 5G, and Bluetooth 5.1, allowing for greater flexibility in network and wireless connectivities. Improved power efficiency. As the power consumption becomes growing concern, future motherboard may incorporate more power efficient design and features such as optimized voltage regulation and power delivery. Means here it is said that the future motherboard will increase the power consumptions as the demand for the motherboards and other computer applications will be more. So it will use more power, and so the electric consumption will be more, and it will also and the future and in future will all need to try the motherboard should use the less power consumptions. Advanced cooling. With the increased performance of CPU and GPUs, thermal management will become an even greater concern. Future motherboard may incorporate advanced cooling technologies such as liquid cooling and heat pipe designs. Overall, overall, the future of motherboard technology look promising with continued improvement in performance, connectivity, and efficiency. Expected to drive innovation and push the boundaries of whatever is possible in the PC world. Yeah, as the future, as we can see that in our future generation, there will be more use of computers, and so that's why motherboard will be required. That is, the requirement of it is also more. So, as the requirement is will be more, the working of the motherboard will also need to be more efficient, and for that, the advanced cooling system should be installed in the motherboard. Thank you.